Hi everyone, welcome to my channel. In this video we are going to see NCERT syllabus chapter 1 rational numbers from grade 8. So before getting into the chapter, we'll just have a small introduction. Now on a number line, if I write down 1, 2, 3, 4, what are all these numbers called as from 1, 2, 3 and goes on? You call these numbers as natural numbers. Natural numbers. What if I include 0 with this natural numbers? You call those numbers as whole numbers. So whole number starts from 0, 1, 2, 3 and it goes on. Okay. Now what if I include negative numbers with this minus 1, minus 2, minus 3 and goes on? You call them as integers. So integers will have both positive and as well as negative numbers. Okay. Now say for example, I can say that between 0 and 1, 0.5 lies, right? And similarly, minus 0.5 lies between 0 and minus 1. Okay. Now, how will I write the 0.5 as? If I write it as a fraction, I will be able to write it as 5 by 10, which is equal to 1 by 2. So, here 1 by 2 is a fraction. Okay. And similarly, minus 0.5 is also written as minus 1 by 2. This is also a fraction. So, any number which is written as P by Q, okay, and with Q not equal to 0. Okay, your denominator shouldn't be equal to 0 because any number with 0 as the denominator, you cannot define that number. Okay. So, with your denominator shouldn't be equal to 0. So, this number, writing the number as P by Q format is called as a rational number. So, see here, natural numbers mean starts from 1, 2, 3. Whole numbers mean including 0. Okay. And integers means both positive or negative whole numbers. Okay. And rational numbers means written as A by Q. So, this is the proper definition for rational number. A rational number is defined as a number that can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Okay, these are all the examples. Okay, writing the rational number in a standard form and all we'll see later. Now, for now, just understand the definition for rational numbers alone. Now, this is the property. These are all the 4 basic properties which we are going to see now. Okay. Closure property. Closure property means take any two numbers A and B. Okay. Now, if the addition of A and B also belong to the same group, that is you are taking two numbers from a group. Say for example here from whole numbers. Okay. So, if the addition also belong to the whole numbers, okay, then closure property is true. Okay. So, two numbers taken from the group means, okay, the addition should also belong to the same group, only then it will be closed. This you can try for multiplication, division, subtraction, and for 4 different operations also you can try. Okay. Commutative property means you are taking two numbers A and B. Okay. Here you are changing the order. See, A plus B is equal to B plus A. Even if you change the order, if you are getting the same answer, if your LHS is equal to RHS, then the commutative property is true. Commutative property means the order of the numbers are changed. Okay, and you will be taking only two numbers here. Okay, whereas for associative property, you will be taking 3 numbers and here your grouping is changed. See here first A and B is grouped and then it is grouped, you are adding with C. And the other way you are grouping B and C and you are adding with A. You are changing the grouping. So, even if your grouping is changed, if your LHS is equal to RHS, then associative property is true. Okay. Now this one is distributive property. So again here you are taking three numbers and you are using both multiplication and division. Okay. So first you are adding B and C and you are multiplying with A. Okay. If you are doing this way, then the number which is outside the bracket, no, it can be evenly distributed to the number inside. So distributive property means you are evenly distributing a number to the numbers inside the bracket. Okay. So that is distributive property of multiplication over addition. Okay. This is just the introduction. Now we will see in detail. Okay. You would have already learnt about the operations, that is the properties and all of about a whole numbers, about rational about integers already. So now let's directly get into the properties of rational numbers. First property is closure property. So you are going to check every property for all the four operations. Okay. So first one we'll check for addition. So what I will do is, let me take here, generally rational number is taken as Q here. Okay. So let's take two numbers A comma B from rational number. Okay. So here we are taking 3 by 5 and 2 by 5. So what is closure property for addition? The addition should also belong to the rational number. Okay. So if I add 3 by 5 plus 2 by 5, see I am getting 5 by 5, which is also a rational number. Okay. So for rational numbers are closed under addition. Okay. Now the same way we'll try for subtraction also. So we'll take two numbers, two rational numbers we'll take. One is 5 by 6 and 1 by 3. For subtraction what you will do? You need to subtract. Okay. 5 by 6 minus 1 by 3. So 5 by 6 minus 1 by 3, you will have to take the LCM. 1 by 3, so it is 2 by 6, which is 3 by 6. Okay, so here it is 1 by 2. See, this is also a rational number. So for subtraction also it is true. So rational numbers are closed under subtraction. Okay. Now next one we are trying for multiplication. Okay. So again you take two numbers, minus 3 by 4 and 2 by 7. Now let's multiply and see and check whether the product also belongs to the rational number or not. See, 2 gets cancelled, it becomes 2. See, it is minus 3 by 14. Yes, this is also a rational number. So multiplication also it is true. Now let's try for division. Let's take two rational numbers. It can be either positive or negative. Okay, any number, any rational number you can take. How will you simplify this? First you will have to convert the division to multiplication by reciprocating this number. You remember, we would have done this in grade 7 and then you will simplify. So you will be getting minus 5 by 6. Yes, this is also a rational number. So rational numbers are closed under division also. So this closure property is true for all the four operations. Now, next one is commutative property. Again, this property also we are going to check for all the four operations. Okay. So, first one, addition. So, let's take two numbers. See, I have taken 1 by 5 and 2 by 5. What is commutative property? You are changing the order. So, here I have taken two numbers. Okay, so the first number you will take as B, A, and second number you will take as B. Okay, first let's add in the first order 1 by 5 plus 2 by 5. See, what are you getting? You're getting 3 by 5. Now let's change the order. Let's add 2 by 5 plus 1 by 5. See, again you're getting 3 by 5. So even if you change the order also, it is true, right? LHS is equal to RHS. Therefore, commutative property is true under addition. Okay. Now the same way you will try for subtraction. Let's take two numbers. See, here I have taken 3 by 8 minus 5 by 8. First we will do. Okay. So the numbers that I have taken are 3 by 8 and 5 by 8. Okay. So first let me add 3 by 8 minus 5 by 8. What I am getting? Denominators are same. So I will subtract the numerators alone. So I will be getting minus 2 by 8. What if I change the order? That is 5 by 8 minus 3 by 8. See, I am getting only 2 by 8. Are they both same? They are not equal. This is negative, this is positive. So for subtraction it is not true. Okay. Now multiplication we'll see. Again let's take two numbers 1 by 2 and 3 by 2. First let's multiply 1 by 2 into 3 by 2. First, because you are changing the order, right? 1 by 2 into 3 by 2 is 3 by 4. Now let's multiply 3 by 2 into 1 by 2. We are changing the order. See, again we are getting only 3 by 5. Same answer. Therefore multiplication is true. Okay. Now division. We are taking two numbers, two rational numbers, 2 by 3 and 1 by 4. So first let's divide 2 by 3 divided by 1 by 4. So what you will do, you will change, right? You will convert to multiplication and you will write it as 4 like this, and you will be getting 8 by 3. Now let's change the order. Let's 1 by 4 divided by 2 by 3. So what will happen? 1 by 4 into, you have to reciprocate this number, 3 by 2. So you're getting 3 by 8. Are you getting the same answer? No. Therefore for division it is not true. Okay. So commutative property is all about changing the order. Now this is the third property, associative property. Associative property means you will be taking three numbers and you will change the groupings. Okay. So here you are taking three numbers A, B, C. Okay. So we are taking 1 by 2. Any numbers you can take. We are just randomly we are checking. Okay, we are changing the grouping. Okay, so what is about, first we are grouping 5 by 2 plus 3 by 2. So 1 by 2 plus 8 by 2. If you have brackets like this, first you have to finish off this, and then only you will have to add with the other number. Okay, so 1 by 2 plus 8 by 2, which is 9 by 2. Okay, now in the second thing we are grouping first two numbers, that is 1 by 2 plus 5 by 2, and then we will add with 3 by 2. See, what is 1 by 2 plus 5 by 2? It is 6 by 2 plus 3 by 2. You are getting 9 by 2. So LHS is equal to RHS. Therefore, addition is associative. The same way we will try for subtraction also. Okay, take three numbers. You have to apply subtraction here. So you try with B minus C. First we will group. Okay. So what is this? I will do and work out and show for you. Okay, 3 by 4 minus 5 by 4 minus 7 by 4. So it is 3 by 4 minus, what is 5 minus 7? It is minus 2 by 4, right? So 3 by 4 minus into minus is plus 2 by 4, which is 5 by 4. Now we'll have to change the grouping. Okay, 3 by 4 minus 5 by 4 minus 7 by 4. So first we'll have to finish off the brackets, right? So what is 3 by 4 minus 5 by 4? It is minus 2 by 4 minus 7 by 4. Denominators are common, means you can combine the numerators. So it is minus 9 by 4. See, you are not getting the same answer. For subtraction it is not true. Okay. Next, for multiplication. So for addition it is true, for multiplication it was not. Now we'll try for for subtraction it was not true. Now we'll try for multiplication and division. The same way only. Take three numbers. Now you do the same thing for multiplication. See, for multiplication both the numbers you are getting LHS is equal to RHS. So for multiplication it is true. So it is associative. Similarly for division you try. You change the grouping. See, here first they are grouping B and C, and here they are grouping A and B. Okay, and you try. See, you won't get the same answer. So division is not associative. Okay. This is overall operations on rational numbers. Okay. Now the most important property is additive identity and multiplicative identity. Okay. Now see here, I am going to take a number 2 by 3. With this number, which number should I add so that I will be getting the same number 2 by 3? I should add 0 obviously. Okay, 0 is like a mirror element. If you add 0 with any number, you're gonna get the same number only. Okay, so 0 is the identity element for addition. Okay, now let's try the same thing for multiplication. The same rational number you take. Now with which number you should multiply? If you multiply, you're going to get the same number. If you multiply by 1 only, you're going to get the same number. Okay, it's like a mirror element. So for multiplication, 1 is the identity element. Okay, for addition, 0 is the identity element. For multiplication, 1 is the identity element. So this is about additive identity and multiplicative identity. Now, what is additive inverse now? See, I am taking a number 2 by 3. Now, with which number I should add 2 by 3 so that I will be getting the identity element 0? See, with x, if I just subtract minus x only, I will be getting 0. Like similarly, 2 by 3, if I add with minus 2 by 3 only, I will be getting the identity element 0. Right? So, for 2 by 3, minus 2 by 3 is the additive inverse. Additive inverse, which is for the number 5. Say for example, any number. If they are asking you to find the additive inverse of 5 by 8, your answer would be minus 5 by 8. So just change the sign and write. Additive inverse means you will just change the sign and write. What is multiplicative inverse now? Say for example, 5 by 8. With which number I should multiply this 5 by 8 so that I will be getting the multiplicative identity 1. If I multiply by 8 by 5 only, I will be getting 1. See here, 8 gets cancelled, 5 gets cancelled, and you will be getting 1. So your question is, if you are asked to find the multiplicative inverse or the reciprocal, just reciprocate the number and write. You will not change the sign. You will only reciprocate the number. Okay, this you need to remember. Okay, for additive, additive inverse, you will change the sign and write. For multiplicative inverse, you will just reciprocate the number with the same sign and write. Okay, these are all the properties of rational numbers. Okay, we have seen additive identity, multiplicative identity, additive inverse and multiplicative inverse. Okay, now the next video we'll see exercise 1.1. Okay, thank you.